next talk is going to be sort of the evolution of this conversation is how do we build technology that can help us grow food? And I want to bring on our next guest, Barbara Belvisi, who is building, I think, one of the more inspiring companies on this planet right now, or solar systems beyond this planet. Barbara, are you with us right now?
Yes, I'm with you. Sorry for before. I'm
That's
changing
okay.
seats because of the light. Yeah,
Is
okay, cool. Can you hear
raising
me?
money all over the world and has incredible projects that are happening both on this planet and beyond. So I'm really excited to hear from you, and I know everybody's going to be inspired by what you're doing. So thank you for being here.
Thank you so much. Thank you for having me, Brad. It's a great pleasure to be with you today, guys. I'm happy to. So I'm here in New York. This morning was a very important time for the aerospace industry. As you all know, SpaceX is going IPO and actually making a lot of people very rich, and we expect this money to help financing the future, both on Earth and in space. The technology that will be needed to preserve life on Earth and expand it in space. I'm happy to share some, I have a presentation for you guys to get to know a bit more about what we're building. Feel free to interact, ask questions. So Interstellar Lab, we exist since 2018. Initially, actually, my background is I did most of my career in finance. And when I turned 30, financing other entrepreneur building crazy things like a lot of robotics, AI and IoT back in the days. In 2017, I left this career in finance and I started to Interstellar Lab from NASA Ames. So I went to NASA and I had this vision of building greenhouses in space so we can make life multiplanetary and at the same time use the technology back on Earth so we can provide better farming solution to grow plants and food in a more sustainable way. So that's what the mission is about: preserve life on Earth and expanding to space. I'm saying that we're in the business of greening the galaxy, and we start with Earth, we go to Earth orbit, the Moon, and Mars. But what we build is this piece of technology. So it's controlled, AI-controlled greenhouse system. We call them biopods. So this one is we have different model, different size. This one is the first. So it's called Model 1. So it's an inflatable structure. It's 47 feet long, 17 feet tall. It doesn't look like it through the picture. We try to put humans next to it for people to get a sense of the size, but even in picture, it doesn't show it how large it is. Inside the white shell, you will find all the atmospheric, hydraulic, all the system that the machine is using to recreate specific atmospheric conditions. Inside the bubble, the inflatable structure, which is sealed from the exterior world, this is where we recreate all the atmospheric condition. And this particular greenhouse is actually coming from an initial lunar greenhouse concept that we submitted to NASA in 2019. And this year, this product was awarded by NASA as one of the best Earth application of an initial space concept. And I'll dive a little bit more about that. So we've always been doing like the back and forth between Earth and space, how space is helping us designing very complex system that needs to be super efficient in terms of resources and energy we use, and how we can leverage this engineering to bring that back on Earth to develop systems that are more autonomous and efficient in growing plants. We're a small team, 25 people. It's actually, I'm going to pass and go more into the technology. So 25 people, very engineer driven. I love the team. We expect to grow fast this year. And expand more in the United States. We have great people on board, whether it's a CEO of XPRIZE, Anusha Ansari. I know Brad, you know her, and she's been early astronaut as well. Bruno Messonnier was an AI entrepreneur. Greg Autry, who worked as a liaison between NASA and the White House. So a lot of entrepreneurs on board. We raised 15 million. To date, we just onboarded. We haven't announced it. We are announcing it at the end of this month, but we onboarded John McNeil, the former director of Tesla, through his fund DVX. He's been a very large contributor to the 15 million seed round, and also Cam Gafarian. So there is one space trillionaire now. There is three space billionaire. He's one of them, and Cam just joined our investor group. So we're very grateful of the people we have on board. 2 locations. I'm French, as you can tell. We have 1 location in south of Paris, another one at Kennedy Space Center, where we build the food production system for NASA, and we're opening the office in New York. That's why I'm here. So the vision of the company is really from Earth to Mars. Is how can we build a system so we can preserve life and expand life beyond our planet? It's a controversial concept and idea, but what we're trying to show to people who believe, why are we going to space? Why are we doing so much? Why are we investing so much on space exploration compared to what we have to do on Earth? Where we're trying to, and we're proving it by doing it, that actually space unleash creativity, engineering to a certain level that we can benefit tremendously on Earth. And whether it's through, the work that Planet has been doing, for instance, and with all their satellite and mapping the Earth and being able to understand much better our biosphere and the climate on our planet, or very, simply, or with Starlink and the connectivity that they're bringing, or with the technology, like how a greenhouse, a lunar greenhouse, how does it serve the Earth? And so this is the one that we built in 2020. Since then, we built multiple ones, but that's kind of our iconic product. And it's the one we received this year, the recognition from NASA. So it looks like a spaceship, but it's designed for Earth. It will not work on the moon or Mars. And this is the one that we use to build our AI. So we grew a lot of different species, and we recorded camera, sensors, data acquisition, to really understand what is the climate that we need to recreate and how we can automate that. And from that data, we created the AI that is just leveraging this data, understand what it has to do in terms of the humidity, the temperature, atmospheric condition, the lighting, and recreate autonomously on those conditions. It's been an iterative process. We've been doing that for 5-6 years. So we have a lot of experience on what's not working, and we change a lot of our growing system. We moved from hydroponics to hydraulics to aeroponic system. Now we are really into fog pony, which is a very thin droplets of water full of nutrient solution. There's no nozzle. It's a membrane vibrating. So it's much better. There is less maintenance. They don't clog. So think of what we do as a very advanced, indoor farm solution packed into a greenhouse that we can deploy anywhere. That's the main difference with existing indoor farm companies, that our system can be deployed, next to their facility, next to, that we need access to power. We don't need to be plugged into a water source. You can just fill up the water tanks. And then it's larger and bigger than a container farm. And so we have more modularity inside. So we do dwarf trees, we do a lot of perennials. We can do microgreens, but we don't see, for us, microgreens and leafy greens are, everybody can do it. So we're really focusing on things people usually you don't do in indoor farm greenhouses. That was the AI that I was telling you about. Of course, it's called Gaia. In French, AI is inverted. So it's EI, so it fits perfectly without a general artificial intelligence approach. But so for the user, it's just basically speak to the AI. Of course, you can watch through a dashboard everything that is happening inside, but the concept is really for the farmers not to have to do that much in terms of controlling the climate, just to be here to to say hi to the plants, to do the seeding at the beginning and the harvesting. That part we don't want to automatize. We want to leave a little bit of human interaction. 3 markets: the Earth, which is the most obvious one, the largest one right now. This is where people can actually buy greenhouses. Though the moon market is started, the low Earth market started, the moon is starting, Mars, there's nobody there to buy us a greenhouse. But so the botanicals. And so we want to go towards food, but the food to be competitive in the food market, we need to decrease the price of our technology. So we started with high value crops, and therefore we went after the top ingredient company, cosmetics, nutraceutical, and we sell them mini pods. The equipment for research is 150K, and then they pay. Sorry?
No, go ahead. Go ahead.
So that's the research pod, and then we have the large pod that we send to our customers. It starts at 500K. So that's quite for farmers that are not selling high value botanicals. It's quite an investment. So we are not there yet at a stage where we are able to mass manufacture and decrease the price of our product. We're getting there. But as I mentioned, we started with, the high value crops, the flowers, because our equipment is, quite expensive. And it has to make sense, economically speaking, for a farmer to buy it. But again, it goes back to what they're growing inside. So we started with the big ones. L'Oréal is our biggest customer. They have huge problem when it comes to the supply chain for their natural ingredients. So every year they're buying from all over the world, from different farmers, a lot of different species. And some year there is a shortage because of climate change, because of geopolitical constraints. There have been issues with kids working on the field as well, so they had to stop the sourcing from this and this country. And so we are providing them a solution next to their extraction facility, and we're localizing the production of some specific plants. They're not trying to replace completely their existing supply chain, but it's more of a risk mitigation and integration of supply chain. For instance, there is a plant that they source in Madagascar, which is called Centella, which is very popular for skincare products. They will need to buy thousands of biopods to cover the demand, which is very, very high for Centella plants. Here we are, it's just going to be a fraction is going to come from us, but at least they will know they will constantly get the same quality. And also, we are in this logic where we don't want to replace what's existing. We want to provide a solution for when there is a risk that needs to be addressed. Until we reach a point again where the technology is much more affordable and we can scale it to a lot of many farmers. But so main focus natural ingredients to start. We specialize in flowers from alpine flowers like Edelweiss to lily of the valley, jasmine. What we did recently, we work a lot on orchids, roses. Currently working on rose because we have a mission, also a space mission. We're going to grow some roses in space. And so this, like, initially we designed this lunar greenhouse to use less water, optimize the energy consumption, and accelerate the cycle of the plant growth. And it happens to be checking like all the boxes of the biggest problem of supply chain of sourcing these high value plants our customers have. So it's we hope it's going to convince other folks that there is a benefit as soon as companies are trying to have this terrestrial application and not put in opposition space and earth. I think we're going in the right direction. Those are some of the this is happening this year. The construction, there are actually going to be 2 installed at this place, and here are the new the scaling part that we're working on with one of our customers. A lot of companies interested. I can go on for yes. I can see Steve has a good question.
Let me ask you a question. This is next level, almost sci-fi type of technology. Can you see a time in the future where this type of technology could be available to communities to help their food growth?
I think it's a question of scaling the product and reducing the cost of the hardware. It's actually not that expensive compared to existing greenhouses system. So I think it's more for the company to have the people, to have the team that can go to this community, present the technology, finding the right financing structure. So we can, support the installation of this farming system, and then it's very easy to use. So this is the part that is, The power thing is, again, we need power, but so it goes down to like reducing the cost of technology, which we've been doing already over the past years, and then just being able to manufacture so we can address the demand. And this is part of our plan. Like this is where we want to go. But we still, we need to raise more money, have a more structured balance sheet as well. But we will get there. We'll get
You're
there.
on the right track for sure. I'm going to let Steve ask a question and then we'll move on. But Barbara, thank you.
Thanks, Brad.
Steve, go ahead. Unmute.
Yeah, Barbara, thank you very much for your presentation. It's really, really wonderful. Now that you're in France, that's good. Can you hear me?
Yep.
Yes, I can hear you. Yeah.
Let me throw something out for you. Just a little nugget here. I'm going to ask you a simple question because you're Interstellar. Why are Martians green?
Well,
why are Martians green?
Are Martians green?
Yeah.
Are you sure they're green? I'm not sure they're green.
Well, at the end of the day, that's a myth, but it's not a myth because they figured out how to travel interstellarly without ever having to bring their lunch. What I want to talk to you about, suggest to you as an idea, okay? Just a little bit of fan, is that aliens or interstellar travelers have developed a skin that has photosynthesis in it. Has a suit that has photosynthesis in it. So what it does is instead of having to bring all the food with you, you have nutrition right on a suit. Yes, so you have photosynthesis. So you have algae, or for example, or you embed that into a suit. Use the same technologies as osmosis through like a patch, and then you just expose it to sunlight, throw some water on it, and lick a rock every now and then, and now you're feeding yourself. Just an idea.
I think it's really cool. It's a cool concept. Well, it will have to be integrated with the spacesuit. And maybe we can reach out to our friends at Axiom and be like, "Hey, dude, you just got a nice spacesuit. Maybe let's put it, some silver in it."
Well, think about it. It could be used everywhere, and not what I'm saying is not everywhere. We're on our little bubble over here, our little blue rock. There's a lot of people out there that are starving. A lot of things you can do with food, but nutrition may not be able to fill their bellies, but you can start generating energy and food for human beings as if they're plants. And secondarily, it's also regenerative because photosynthesis sequesters carbon and produces oxygen also in your little space capsule.
Yeah.
And our space capsule is called Planet Earth. So this is another area, an idea that I thought, well, since you're a stellar and comme vous êtes française, c'est comme ça. We get a little bit of invitation, ideas that we can potentially discuss. Those are some of the things that I thought
think it's cool.
would be interesting for a conversation. Just an FYI.
Thank you, Stephen. Thank you very much. Barbara, anything you want to share with people how they can continue to track what you're doing?
Sure. Well, so we have a couple of space missions coming in. We just announced a partnership with VAST. We're flying with them in 2027. There are two French astronauts, Thomas Pesquet, including and Arnaud, who are flying with VAST. They're going to carry our mini greenhouse chamber in the station. So starting next year, for 3 years, we'll be in orbit, conducting a series of experiments on how plants are reacting to microgravity. Axiom and Voyager, we adore those guys. We don't have a date yet for flights, but it's coming soon. And we're going to the moon with Astrolab and SpaceX. So we have a mini greenhouse for lunar environment that will be deployed probably 28 as part as Artemis 4. It's still working in progress, but we have the agreement with Astrolab. With different food production system, you'll see NASA will release more things about what we're doing. The thing I wanted to share with you is Mission Little Prince. We are actually launching next week. I will share with all of you guys the websites. Brad, if you agree with that. The Mission Little Prince is a non-profit mission, and we sign it in partnership with the Antoine de Saint-Exupéry Foundation, which is the foundation run by the nephew of Antoine de Saint-Exupéry, who wrote the book The Little Prince. And so in this book, The Little Prince, there is a little prince who's leaving his planet to go visit other planet and the Earth. And when he was on his planet, he was in love with a rose. But when he left, he misses the rose a lot. So we are going to grow rose in space and we call it Mission Little Prince. So we're bringing a rose tree on Earth orbit in 27, then we're bringing one on the moon in 28, and we want to bring one on Mars. It's it's hard scientifically speaking, and engineering is tricky. Roses are hard to grow, but we're very happy with the recent test that we made, and it's looking pretty good. And it's a mission to inspire. It's really to make people remember that space exploration is about wherever humans go, we have this responsibility of carrying life with us. We are the keepers of the gardens. We are the seeders of life, we may say, or maybe it's too presumptuous, but so that's a mission to inspire. So when we look up the sky, we'll be like, there is something that we will not see, but it's there, and it's a rose growing on the moon. So voila. These are my last words, and you can reach out to me with my email.
Thank you for making time. We know you're in the middle of a very large raise. We wish you the best, and hopefully this can both change life on Mars and life on this planet as well in the future. But good job. Thank you so much. And now we're going to go to the next panel. Barbara, thank you.
Bye.